Mini lesson 43, variation. Okay, so in math we have 3 different ways to describe variation. You can have direct variation, inverse variation, and joint variation. If you look at all 3 of the different types, notice there's one variable that's in common. That's k. We call this the constant of variation, and in each problem, k is a constant. In area formulas, for example, pi is a constant. In the area of a circle, pi has to always be used in the equation, so that's known as the constant. But if you have a made-up equation similar to the second example I have, it's not made up, it is probably a physics equation, but needless to say, I can't describe it at this moment. K is a constant. So the way that you read variation, the way that it gets described to you in a word problem, is it'll say y varies directly as x. The minute it says the word direct, you know it's direct variation. You know that it's going to multiply by some constant. If it says inverse variation, it looks similar to y equals k over x, where the constant is on the numerator and x is on the denominator. Notice the key phrase inverse variation. Y varies inversely as x. Last but not least, joint. It reads z varies jointly as x and y. So notice there's 2 variables, and that would mean there's multiple things. So it's varying jointly. Okay, there can be multiple variations within a problem. That's another thing a lot of people, look at the second example, right? We're going to describe that in a minute, but notice there's a denominator of some variable. There's multiplication of 2 variables with a constant, so we know that we're having, certain variations. So let's think about it. Let's look at the area equation. You have area is equal to pi times r squared, right? So how would we read this? Well, let's say the area varies directly as the radius squared. Notice you have to include that the radius was squared because that's part of this equation. So you have to describe every part. Okay. I encourage you to pause, try the second one on your own, and then check it. Just use the variable names since we don't necessarily know what they all mean yet. I'm going to just go with it. So m varies. We always start with the variable on the outside is varying. And then this is how we have to describe it. So notice you have j and m squared. So that's a joint variation. So we can say varies jointly as j and m squared. And inversely as r. And just like that, you've just described a variation problem. So now let's work the opposite way. From the description, write the equations. So given the equation of variation described, use k as the constant of variation. Here are your examples. A, v varies directly as the cube of r. B, w varies jointly as x and y, and inversely as z. And lastly, c is h is directly proportional to t and inversely proportional to z. I encourage you to pause. I'm just going to go over the answers. V is equal to k r cubed. For B, w is equal to xy divided by z. And last but not least, h is equal to t over z. Oh, quick mistake, right? You have to look over again. I'm going to use the directions as my hint. I'm showing you this as an example of what many students will do. They write exactly what they read. They forget that there's a constant of variation. Remember, we have to include the k like we did in example A. So we're missing a k, let's include it. We're missing a k, let's include it. Okay, folks, have a great day.